Okay, so we're going to start off with number 49. 49 is very, very similar to the one that we did yesterday. We have M1, the mass of the bullet, is going to be 10 grams, so that's 0.01 kilograms. And ballistic pendulum, so M2, is going to be 2 kilograms. And so we have the bullet coming in at some certain velocity. It's going to hit the pendulum, connect. Those two things are going to go here with some velocity, and then it's going to rise up a certain distance. So almost identical to the one we did before. So at this point in time, I'm going to have you pause and just put in your answer so we can check it here. Okay, so now that you put in your answer, what do we know? We know that it's going to raise up a distance, a height of 12 centimeters, so 0.12 meters. So the first thing I'm going to do is I'm going to use loco E here, where the kinetic energy, the change in kinetic energy of the bullet and the bob will equal the change in potential energy of the bullet and the bob. So I can say that's going to be equal to 1/2 M1 plus M2, because it's two of them together, times velocity squared is going to equal M1 plus M2, because they're hooked up together, times G times delta Y. So we go 1/2 of 2.01 times V squared is equal to 2.01 kilograms, I'll leave that off, times 9.8 times the 0.12. So I calculate that out. I get 2.01 times 9.8 times the 0.12, so potential energy of 2.36376. Now I'm going to multiply that by 2, divide that by 2.01. So that gives me a velocity squared of 2.352, so take square root. So my V is going to be 1.533 meters per second. Now this is the velocity that the bob and the bullet have right after the collision. So now I can use loco P. So the total momentum initial is equal to total momentum final. So I've got P1 plus P2 is equal to P. So M1 V1 naught plus M2 V2 naught is equal to M1 plus M2 times V. Now this V is that one, because that's velocity after the collision, and it's also the initial velocity going up. So plug this in, I get 0.01 times V1 naught plus, well, that goes to 0, because initially this thing was at rest, is going to equal 2.01 times that 1.533, and it should be 1.534. So 2.01 times my velocity, divide that by the 0.01, so I get 308. So my velocity, V1 naught, should be 308.3 meters per second. Okay, so that's 49. Okay, so now we're going to look at 51. And 51 is a little bit tricky because they don't actually give you an initial velocity. So I'm going to pause and just for a second, make sure you get an opportunity to write down what your answer is, and then we'll compare. Okay, so I'm going to start off with this thing. I'm going to say let V naught equal V naught. And so the initial velocity of the car in both the Camel and the Moose is going to be referred to as V naught. Now I could have made up a number if I wanted to, but I'm just going to leave it as V naught. So what I'm going to look at here is there's definitely a collision. So I'm going to use loco P to find out the velocity after the collision. So I know that in loco P I've got P1 plus P1 naught plus P2 naught is going to equal P. So this is M1 V1 naught plus M2 V2 naught is equal to M1 plus M2 times V. So they do give us the velocity, or so they do give us the masses. So you know that M1 is going to be the mass of the car, so 1,000 kilograms. And the M2 is going to be the mass of the Moose, or 500 kilograms. So initially the Moose is at rest, so that goes away. So we've got 1,000 times V naught is equal to 1,500 times V. So if I want to find the speed at which the moose car situation is going after the collision, I'm just going to solve this for v. So my v after the collision is going to be 1,000 over 1,500 v naught, or I can just put it as 2/3 v naught. Okay. So now what I need to do is I need to find out the kinetic energy before, the kinetic energy after, and then find the difference. So kinetic energy before, K naught, that's just going to be 1/2 of m1 times v1 naught squared. So it's going to equal 1/2 of 1,000 times v naught, don't forget the square. So it's going to equal 500 v naught squared. So my kinetic energy, 500 times whatever the speed was, squared. My final kinetic energy is now going to be 1/2 of m1 plus m2, so 1,500 in this case, times v squared. And I already found my v down here. So this is going to equal 1/2 of 1,500 times 2/3 v naught. Don't forget the square. Now I'm going to expand this whole thing out. So to show you where I'm headed here. So if I square the 2/3 v naught, what I end up getting, this becomes 4/9 v naught squared. And then the 1/2 of 1,500 is 750. So if I combine these two together, I end up getting 750 times 4/9 is going to end up giving me 333. Yeah, 333.3 v naught squared. So we'll just take the 750 times 4. Let me just double check that. And then divide that by 9. Yeah, 333.3 v naught squared. So if I want to find out the percentage lost, I'm going to find the difference between these two. And so if I take 500 and subtract off my 333.3, the K lost is equal to 166.7 v naught squared. So now I can find percent lost by taking my 166.7 v naught squared over my original kinetic energy, the 500 v naught squared, and that's going to give me 33% of my energy was lost. Okay. Now I'm going to do the exact same thing but with a camel now. Okay. So I'm still going to use the loco P. So loco P. So P1 plus P2, I'm not going to go all the way through it, equals P. But you end up getting 1,000 times V naught is equal to 1,300, because now the camel's mass, so now M2 is equal to 300. 1,300 times V. So my V, my speed after the collision, is going to end up being 10/13 V naught. So I just took the 1,000 V naught, divided by 1,300, gives me 10/13. So I go back through, my original kinetic energy is still the same. So that 1/2 of 1,000 times V naught squared, so that's going to equal to 500 V naught squared. But I got to find my new kinetic energy. The new kinetic energy, 1/2 of 1,300, because it's both masses together, times the new velocity, so 10/13 V naught. We have to square that whole thing. Okay, and so I'm not going to bore you with doing it, but you end up getting, in that aspect, 384.6 V naught squared when you pop that through. So that means the K lost is just the difference, so 500 minus the 384 point blah blah blah, that's going to give you 115.4 V naught squared. So again, 5% lost. Let's straighten this up just a touch. Percent lost. We'll do the 115.4 V naught squared over the 500 V naught squared, and I end up getting 23% is lost. So in general, as the mass goes down, also the percentage of kinetic energy also goes down.